alarm. Start recording. Okay. Okay, oxygen is O2. It's one of our diatomics. We have plastic, which is another thing that is made out of some ratio of carbon and hydrogen and oxygen, but the numbers down here are probably different, and we don't know what they are, so we'll just put that. And then potassium. Anyone remember the symbol for potassium? Hey. Sand. What kind of a thing is sand? Do you think it's an element or is it a compound?
Compound.
It's a compound, and it's actually made of silicon and oxygen, SiO2. And because it is made of a metalloid plus a nonmetal. Ooh, what's a metalloid and what's a nonmetal? Tell your partner what you can remember about those. What's a metalloid and what's a nonmetal? Another thing that we can draw on our periodic table is we can draw a... What am I drawing? I'm drawing a staircase. Yes? And what does the staircase separate? It separates the metals from the nonmetals. Okay, so you start at the tippy top corner here, right up here, and then you go down and across and down and across and down and across and down and across. Which side of the periodic table has the metals? The left side has the metals. So if we go to the left, these are the metals. And if we go to the right of the staircase, we have the non-metals. Now we talked about metalloids. If the metals are on the left and the non-metals are on the right, yes? Of course. If the metals are on the left and the non-metals are on the right, where would you expect to find the metalloids? You would expect to find the metalloids right beside the staircase. Okay? So metalloids, silicon and germanium. Boron, not aluminum, strangely. Basically, if you go to one of the across parts of the staircase, you go above and below it, except for not aluminum. But it should make sense to you, because what do you know about aluminum? Aluminum is a what kind of element? Think about aluminum foil. What is aluminum foil? Is it metal, non-metal, or metalloid? It's a metal. It's shiny. Yes, it's a solid. Aluminum is a metal. But other than that, all the elements beside so arsenic, antimony, tellurium, polonium, and then we're not actually going to worry about astatine and tennessine because, again, they're too far down. And they're radioactive, and we don't need to worry about them. So are we good with that? So these guys are the metalloids. Touch the staircase. But not aluminum. So everybody touching the staircase is a metalloid except for aluminum. If you want to include astatine and tennessine, you can, just to make it like less complicated. Sure, why don't we? There we go, astatine, tennessine, whatever, doesn't matter. Biologists often get very excited about the elements at the bottom of the periodic table. If you have a chemistry teacher, though, we're like, yeah, whatever. Nothing happens down there because everything's too radioactive. It doesn't stick around long enough, so we just don't worry about it. Okay? Now, if you have a compound made of a metal and a non-metal, that would be like, say, iron and oxygen. What kind of a compound do you have? Let's go back to our other page here. Here was our iron, which is a metal. Here's our oxygen, which is a non-metal. And we have two different types of compounds that you've learned about in grade 9 and in grade 10. See if you can chat with your neighbor and remember the two types of compounds. If you're having trouble thinking of them, one of the names starts with I, the other name starts with C. What do you think I stands for? Ionic. So there are ionic compounds. Ooh, what was it? Covalent is the other kind. So an ionic compound, what types of elements? Remember, our types of elements are metal, metalloid, and non-metal. Ionic compounds are made out of two of those, usually anyway. Anyone remember? Metal plus non-metal. Okay, so we have a metal plus a non-metal. And here's just a quick little eyesight check for you. If you cannot tell the difference in color between the word metal and the word non-metal, then you'll want to get your eyes checked because you might have red-green color blindness. I've actually discovered 2 students who have red-green color blindness in my 28 years of teaching. They were like, I don't see the difference between those 2 lines on the graph, Ms. Spence. And I'm like, oh, wow. Okay. So anyway, if you can't see the difference between metal and non-metal, go to your eye doctor and get it checked. There's nothing you can really do about it. You've been living, if you didn't know and you've been living your whole life with it, then you'll be fine. It's no big deal. Okay. All right, covalent. What is covalent normally made of? It's made of usually just one type of element. What is it? It's usually made of non-metals. Whoa, what happened here? Oh, it got unscrewed. Okay. Hang on a second. Oh no. Okay. Uh-oh. Uh-oh. Oh, okay. Well, let's see if this one works. Oh, it does. Good stuff. Okay. Non-metals. Non-metals only. But also sometimes metalloids. Oh, it screws on backwards. That's exciting. Cool. So if we then go and we look at our compounds that we have so far, what about this iron oxide? What about this iron oxide? What kind of compound is that? That is ionic. And look, it's made of, guess what? Charged particles. Those are ions. Yes? SiO2 is made from a metalloid plus a non-metal. What kind of compound is that? That is a covalent compound. So we have a covalent compound, we have an element, we have an element, and we have an element, so sand is the odd one out. Do we have any diatomic elements in that last row? Yes. Yes, we do. Who is the diatomic element in that last row? Bromine. Bromine is Br2. Okay. And we're going to take stretch break. So everyone stand up. All right, so first thing we're gonna do is we're gonna stretch up high, and then we're gonna bring our hands down and back as far as we can behind us. Oh. And then you're gonna clasp your hands behind you. And if you can raise your hands up, and if you can't, you can just clasp your hands behind you. Oh, and you can lean forward a little bit if you want to, but you don't have to. You can just there. Oh. Okay, now we're gonna do this. Oh, that feels good. And we'll do the other side. Oh, that feels good. And then we're gonna do this one. And we're gonna do the other side. And now we are going to do some cross body motion, because what it does is it connects one hemisphere of your brain to the other hemisphere of your brain. So we're going to take our right hand and touch our left shoulder, and then we're going to go the other way. And we're just going to do this a few times. Okay. It actually does strengthen connection between the two hemispheres of your brain, which means that your brain works more efficiently. Okay, and now we're going to do it in front. Okay. And now we're going to do. I forget how it goes. It's been too many years since I've done the Macarena. Okay, anyway. Just before we sit down again, let's do some shoulder rolls, because shoulder rolls are always good. Oh. And the other way. And then we're actually going to just kind of hang our head forward a little bit, get a little stretch in the back of the neck there. Shake out your hands. Okay, and now we're going to go again. Okay, we're going to go through this really fast. You got to keep up, yes? Fast, keep up. There are many different materials in the world, but only around 100 elements. These elements can be combined in many different ways to make thousands of different compounds. An element is a substance made up of only one type of atom. Now, sadly, your pictures do not have these lovely colors. Okay, it was it's like, 10 times more expensive to print in color. But copper is made of only copper atoms. Carbon is made of only carbon atoms. And helium is made of only helium atoms. What type of element is copper? Metal or non-metal? Metal. Carbon is a non-metal. And helium is a non-metal. Okay. Molecules. The atoms of some elements join together. What do we call it when atoms join together? We say that they combine, but there's a word that starts with B. Bond, yes. Okay, they bond to make molecules. One of the elements that exists like this is hydrogen. Each hydrogen atom joins up with one other atom to make a hydrogen molecule. Okay, so a hydrogen atom is just one atom. A hydrogen molecule is two atoms bonded together. Do you think that this hydrogen bonded to the other hydrogen is an ionic bond, or is it a covalent bond? Well, hydrogen is a non-metal, and it is bonded to another hydrogen, which is also a non-metal, which would mean that this would need to be a covalent bond. The symbol for hydrogen, or the formula for hydrogen molecule is H2. Since the hydrogen atom is made of two atoms, what do we call it? We call them a, what kind of molecule? Diatomic. Molecule, di means two. Other elements such as nitrogen, oxygen, chlorine also exist as diatomic molecules. A diatomic molecule contains two atoms. So see if you can list the 7 diatomic elements with their correct formulas. You can tell which one I learned first, right? I learned Brinkelhoff first, so that's how that's where I automatically go, but you can go any route you want. When two or more different elements react in a chemical reaction, atoms do not just mix together, they become joined. What is the word for joined? Bonded to one another to make a, now what if we have different elements combined? What do we get? We get a compound. Okay. So here we have hydrogen, which is an element, oxygen, which is an element. Why am I writing this down? It's down here. We have an element, and when we put them together, we get a compound. Now, if we needed to write the reaction for this, how would we write the chemical reaction? Well, we would have hydrogen, H2, plus O2, reacts to give, remember we use an arrow, not an equal sign in chemistry, okay? H2O. What would we need to do with that reaction to make it a happy reaction? We would need to balance it. Do you remember how to balance a chemical reaction? You have to make the number of atoms of each type the same on both sides. Again, we have a whole unit related to that. That's unit 5. But we're going to do it right now. We're going to look and say we have 2 oxygens over here. That means on the right-hand side, we also need 2 oxygens. And we do that by changing the coefficient. Okay, this number right here is called a coefficient. Do we need any other coefficients? Yes, because if we make that a 2, that means we now have 4 hydrogen on the right, which means we need to multiply that by 2. So now we have 4 hydrogen on the left as well. And the reason we need to do that, you can actually see here. What if I did not have this second water molecule here? Right? What if I just had 2 hydrogen molecules, 1 oxygen molecule? You'd be like, hey, what happened to this oxygen atom? It just disappeared. Can we have disappearing atoms? No. And what if we got rid of this hydrogen here? Would that make anything better? Is that a workable reaction? Yeah. Still not a workable reaction. I have 2 hydrogens, but I still only have 1 oxygen. So that's why we need all those coefficients, is to keep the atoms the same from side to side. All right, so compound, you have to have 2 or more different elements bonded together. Is Cl2 a compound? No, because the atoms are the same. Is Cl2 a molecule?
Yes.
Yes. Okay. Molecules of compounds. So here are some molecules of compounds. Molecules are made only from non-metals. What kind of bonds are there then, if they're only made from non-metals?
Intermolecular something.
Ooh, there are intermolecular forces, but we're not going to go there quite yet. Within the molecule itself, when we actually have that little bond in between the hydrogen and the oxygen, what type of bond is that?
Covalent.
That is a covalent bond. So we have only covalent bonds. Water is made of 2 hydrogens and 1 oxygen. What is the formula for water? H2O. Carbon dioxide is made of 1 carbon and 2 oxygens. What is its formula? How many C's? 1. Do I put a subscript there? Nope. Do I put a subscript beside the O? Yes. And the di is what actually what tells me how many oxygens there are. Okay. Have you heard of crystal lattices before?
Yes.
You may or may not have. I know that like you have because you had me as a grade 9, but not everyone has necessarily heard of a crystal lattice. Ionic compounds don't just exist as they do not exist as molecules. So ionic compounds do not form molecules. That should make sense because what are molecules made of? Only nonmetals. And ionic compounds contain metals. So instead, what happens is we get this 3-dimensional crystal. Have you ever seen a picture something like this? Okay, so even if you didn't know what it was called, they are alternating positive and negative, what do we call charged particles? Ions. Okay, so this 3D structure is called a crystal lattice. If I ever call upon you, I forgot your test at home, Cash, I'm sorry. Yeah. If I ever call upon you to draw one in real life, I'm going to only make you draw it in 2 dimensions because 3 dimensions is just way too hard. If you have difficulty visualizing what that looks like, we have a lovely 3D model right here where it goes sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride in 3 dimensions. What do you notice about the positive sodium? What is it attached to? It's attached to green chloride, green chloride, green chloride, and green chloride. So the positive ion is surrounded by negative ions. In the middle of this thing, I have a negative ion, and it is surrounded on all sides by positive ions. Why do they do that? Why do they arrange themselves with positives beside negatives? Tell your partner what you think. Why does the positive have to be beside the negative? How? I thought I got them all. Okay, so that'll do for your parents. I will send a marked change to the office to make sure it gets changed in the computer as well. Okay? Yeah, thanks for dropping by. I'm so sorry about that. So why does the positive want to be beside the negative? Because positive and negative attract. What do positive and positive do? Positive and positive repel. So if you did have a positive beside a positive, if I moved the positive beside a positive, it would try and move away because it would be repelled by the other positive. What do negative and negative do? Negative and negative also repel. We write the formula for these ionic compounds. When we write the formula for these ionic compounds, we use the smallest whole number ratio between the ions. Because does it make any sense for me to go to this crystal and say there are 1, 2, 3, 4, 5, 6, 7, 8 sodiums for every 8 fluorides? Would it make sense for me to write Na8Cl8? No, because what if I had a bigger crystal? Right? I don't know. Let's just say this is 10 by 10. Okay? If it was 10 by 10 by 10, then I would have, say, 1,000 ions, yes? That would mean I would have Na 1,000, Cl 1,000. That gets stupid, yes? Especially because how do you even know how big your crystal is? When you look at a salt crystal, can you see the ions? No. So we just know that the ratio is 1 to 1, so we don't write any subscripts. We just say it's 1 to 1, NaCl. If it was 2 to 1, we would write Na2Cl, okay? So we just write the simplest whole number ratio. So in sodium chloride, there's 1 Na for every 1 Cl, so the formula is NaCl. There's no point in putting actual numbers in there. When we write the formula for water, is that the simplest whole number ratio, or are those the actual number of atoms? Those are the actual number of atoms. It's not a simple ratio. It's not like water is ever H8O4, right? That doesn't happen. Molecules, these are the actual number of atoms. Not just the ratio. So in ionic compounds, we can only know the ratio. In a covalent compound, in a molecule, we know the actual number of atoms. Mixture versus compound. Which of these is a mixture and which is a compound? This guy here has different particles. And if you have different particles, you have a mixture. Now over here we have oxygen and we have hydrogen. Is this a mixture? Or do all the particles look the same? All the particles look the same. Therefore, we have a pure substance. Okay? Now your homework is going to be to read pages 54 to 57 and you're also going to do the questions on pages 57 to 58. So basically read and do pages 54 to 58. Okay, that's all about homogeneous and heterogeneous mixtures, which you have probably seen in the past. Just a brief little reminder for you. Absolutely, yes. Don't forget, if you want to read because I'm here every day during Flex. If Flex doesn't work for you, we can make an alternate arrangement, okay? So if you do want to read any of your quizzes, I am here every day during Flex or at another time if you prefer. Yes. Sorry about that. Oh, yeah. I try, I like to, and I promise you. If I have more glasses, I would do that too, but I don't have to. Because I tend to misplace one, so I always. Oh, your glasses are also purple. Yeah. Yeah.